Hi. Okay, that's better. Hi. Good afternoon. It's still Tuesday, December 10th. I am still that developer dad, and we're going to keep working on this generic filtering mechanism for collections of some arbitrary type because it's way, way better than get by ID, get by name, get by this, get by that, and blowing up your access contracts and your public APIs and so on and so forth. It's way better to have just like a filter endpoint that can take in an array of filter descriptions that then, through the magic of code, get turned into an actual link statement that we can run against various collections of stuff. So, I've gotten a good bit of code for this written during the break. I decided, let's just go ahead and do this apply filter of T thing. And we take in the collection, we build an expression tree to get our filter query. And then we just say filtered.add range collection.where filter query. And then off we go. We could just return collection.where filter query, but let's just go ahead with add range for now. So I'm going to save this. I have to save this over here. Duh. And we're actually running into an exception when we're trying to combine the expressions that come out of this query here. I've added an asExpression_for method to the FilterCriteria class that takes all of the stuff that we've specified and turns it into an expression. But what it's doing is it's emitting a lambda expression, and I don't think we want that. So I think what I'll do is just do this and return the body. Let's comment this out in case we want to come back to it and rethink what I'm doing. Return body. I don't think I need the param anywhere else. Is it used anywhere? I don't believe it is. Find all references. Oh, it is used to get the member expression. So that's fine. That's okay. We'll use that. We'll leave it be. And let's just refresh. What are you doing? There we go. All right. So let's take this out for a spin. And I've got some breakpoints. Namely, pop out here, save the file. Got a breakpoint here where we're building our collection of expressions. And there's another one kicking around here somewhere. Okay, up here as we're getting ready to enter build expression tree. I'm going to pop that here and I'll move it down here. Now, right now, our collection is going to have two things in it, and I want to get one out because of the filter that I'm building. So let's run and see if this gives us any goodies. All right, so our filter expressions, I'm just going to step, let's step in. So we'll take a look at asExpression_for. We get all this stuff and our body on the expression. If you can see it here, you can't really. So I'm going to need to shrink this down a scooch. Here we are. And I'm going to mouse over this body. And you can see up at the top there, it says x.sku equals dm_familiar_free. So that's basically the little where fragment that we want to start combining to build out the actual link statement dynamically. So we'll step out of here. We'll step into the next one. I'm going to step over this stuff. And the body says x dot renewal period is less than 100. Good. And we've got our list of filter expressions. There are 2 of them. Here's number 1. SKU equals the SKU we're looking for. Number 2 is the renewal period is less than 100. Great. And let's try and aggregate them. This is where it was blowing up. Oh, we have an expression body. And we see x.sku equals the value, and also renewal period is less than the arbitrary crap that I threw in there. So we need to build a type parameter with which we will build our lambda expression. Here we go. Here's our lambda. And now we're going to compile this into our query. And that explodes. That's okay. Variable x of type reference from scope is not defined. All right. That means we need to probably either not even use that.
I'm going to check them out.
You know what? Just for laughs, let's say query equals lambda. Lambda. And that doesn't help us. Okay. Dot compile. And let's take a look at some of these overloads. So there's just the default delegate that represents the lambda expression. Delegate lambda expression dot compile. Oh, come on. I want to look at the overloads here. What even? All right, I've got a Microsoft Learn window kicking around here somewhere. Here we go. And I don't want to filter by title. I want to search. Here we go. Lambda dot compile. Executing expression trees. Lambda expressions to functions. Here we go. Into executable IL, blah, 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 blah. Yeah. Important, compiled a method is only available in .NET Framework, not Core. That's fine. Following code demonstrates concrete types used when you compile and execute an expression tree. So there's our expression of func. Expression.compile. Blah, blah, blah. Compile. Following code example, how to represents raising number to the power of 2. Yeah. Come on. Caveats. Just give me the darn documentation on expression.compile. Let's take a look here. So lambda is that. And what I really want is expression.compile method. Here we go. Compile Boolean, debug info generator, examples. For interpretation, returns a T delegate, blah, 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 blah. Debug info generator, sequence points and annotate local variables. Boga, boga, boga. So we don't have a whole pile of stuff there. Query. Let's do this. Var delegate compiled equals that. Drop a breakpoint right here. Run that. And let's see what we get out of this lambda.compile. Just go step over. All right, variable x of type. Subscription template reference from scope but is not defined. Parameter expression node. Visit binary. Yeah. So I'm obviously doing something goofy here. Let's look at more documentation. I got to look this stuff up every time I do these things. Methods, compile, update, expression, methods, accept, add assign, and also convert condition. Can reduce node type. All right, binary expression, conditional expression, constant, debug info. Excuse me. That's a block expression, not what I'm looking for. Visitor stuff. All right. I have why am I shelling out to Microsoft Copilot when right here, Apple I need to convert the lambda variable from being an expression of func to a func of t and bool. Nope. That's not helping me. Expression.lambda. And let's try Copilot again. When I compile, call compile, throwing an error, an exception about the type param in the expression. The issue is that the body, oh, where are we going? Oh gosh, what are you doing? Copilot, you went crazy. Filter expressions, aggregate. Body expression is using a different parameter than the one defined in the lambda. You need to replace the parameter in the body expression with the type param. Are you sure about that? So in that case, stop it. So add criteria. Okay, that's that. Let's come back down to build filter. And I bet if I grab this guy, come up to filter criteria where I'm turning it into that. And I'm just going to do a comment and paste. Filter subject type X, target type as expression for param. I don't think I can do this as expression for out here. I think I need to cut this Yeah. Save. Run back out to filter. I'm going to rename this to convert to expression. And instead of passing this, I'm going to pass a filter criteria. And our parameter expression is going to be, well, let's fix this stuff up first. Criteria dot property name. And let's grab this, copy, paste, paste, paste. And then I've got a member level and his filter subject type. Save. Oh, yeah, I had that value right there. I might pass this in. As a matter of fact, I'm going to rename this symbol to filter type param. Rename type to filter param. All right. I'm going to grab this guy, X him out. Paste him back for just a second. Parameter expression. Filter type param. Type param. Now, X that out. Come back up here. Define the part of the expression that will represent the type we're filtering in the final expression body. And convert to, what did I call that method? Convert to expression? Rename symbol to expression. Convert to expression. And we're going to pass in our filter criteria, type to filter param. All right. And that's going to get us back a slightly different collection of stuff. And we can get rid of this guy because we're doing the exact same thing there. And say type to filter there. And let's just step down to here and see what we get. All right. Let's step in. So we've got our filter expressions. X.skew equals stuff, X.renewal period equal is less than other thing. Cool. We'll aggregate these. So we've got our expression body. So X.skew equals blah, and also X.other criteria. We're ANDing them all together. And we can turn this into an expression that represents our Boolean function that we're going to run on instances of t. So we've got our lambda now. And let's try compiling it and see if we get the good stuff. And we have it. Good. Good, good, good. So, query equals lambda.compiled. And run that bad boy. And we know we're through here. Go. We've gotten past that. I'll eliminate that breakpoint. Step back out to where we were. We've got our filter query. Collection has 2 items. And let's try it. Filtered has 1. Go. Cool. Very, very cool. This is fun. And I wonder, console.writeLine, filter query, just for laughs, just to see what we get for science. Let's run it again. Okay, that doesn't really tell me much. All it's doing is writing out the type name. So, filter query dot, not get invocation list or get method info, target. Let's drop a breakpoint here. And I want to take a look and dig into that filter query object a little bit to see if I can get to where that mouse over debug thingy is. So here's our filter query. Error processing variables request. Oh, bite me. Blah, 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 blah. Let's try and dive through this filter query object. Oh, okay. Yeah. Doesn't like that much. But I bet we can get to that stringified version of it in here somewhere. Let's get rid of that. Drop a breakpoint here. And hit some F5 action. And here's our lambda. Lambda.toString. Oh, look at that. Okay, so what I want to do, just purely for silly logging purposes, I'm going to come all the way up to the top of the file. And I'm going to say private string materialized filter equals string.empty for now. And then down here, let's just cache this. I spelled it wrong. So let's rename the symbol, fix my spelling. Materialized filter equals lambda.toString. Save. Run again. And just go. And I think I'll promote materialized filter back to the base class. So cut that, drop it up here, make it protected. And in toString, sb dot append line go. Here's the materialized filter. Cool. Our filtered count is 1. All right. Now, string.empty. Protected, abstract, void, build. Build. Rename. Build filter. Yeah, that works. Now, func. Filter query. make that nullable. Okay. Filter query. Rename this to just query equals filter query, build expression tree. Save, run it. Okay, cool. Now, let's come back out to our filter tests. Whoa, don't want to do that. We're going to cut. Okay. So filter equals filter apply, call filtered count. Add a criteria and do it again. All right. Filter equals apply filter call. And I want to do well, let's just grab these 3 lines here. Copy, paste, and run. So here we go. We're adding criteria to our dynamic filter as we go, and that's pretty nice. Pretty nice indeed. Excuse me. Now we've got a few issues in here. Namely, if I try to use a is contained by, I'm going to get into some trouble here because it's going to throw a not implemented. So what I need to do is well, we've got all these operator kinds, right? So let's add a new folder. Operators. And this is going to start to look an awful lot like the stuff I was doing when I was building the rules engine. come back out to operator kinds, collection utilities, dot operators, not operator kinds, just operators. Save. I gotta fix this stuff up. There we go. Pop in here. Update that. Save everything. Make sure it still runs. All right, good deal. So we've still got our filters building out and all of that good stuff. Now, over in this project that I worked on a little while ago, I've defined all kinds of stuff for operators. So type strategies, all that good stuff. And this is neat, but it feels really clunky to me. So I think what I'd like to do is I think we'll use an operator base class. So now if I use an abstract base, then it's got to have the same visibility as all of its child classes have to have the same visibility as the internal, I believe. I could be wrong. We'll find out in a second. Operator base. And we're going to make it abstract. And let's go ahead and set this to internal. Cool. And let's try public class equals operator base. And it doesn't like that. How about I get rid of this internal altogether? Still doesn't like that. All right. So public. Okay. And I'm going to say protected operator kind. Operator kind. Excuse me. And we're gonna protected operator base. There we go. Base operator kinds dot equals. Cool. And the equal operator. Save that. Register known type strategies. Actually, I do kind of like that register known type strategies and using the strategy pattern for this. Let's take a peek at how it works over in this other project. So we've got our base class, the abstract operator base. And let's just shrink that down. So we've got a protected dictionary keyed on type, returns a function, object, bool type strategies. It's got a public operator kind for all of its children, and then we register our known type strategies. And we can evaluate, value test, base value, return, strategy, invoke, etc., etc. And then overload for baseline values. And then register type strategy. This allows us to add new ways of comparing for different types that we might encounter. And then, of course, there's register known types. That has to be implemented on each of the child classes for a comparison operator. And this is pretty darn flexible. But I think over on operator base, I'm going to add public abstract expression. And of course, we have to import that namespace. And I'm going to call it, excuse me, build expression. Return null for now. Oh, wait, there's no body on this. There we go. And I'm going to have to public override expression, build expression, and we'll just throw a not implemented here for now, because this guy is going to have to take in some stuff. And if I come back out to filter and take a look at how this thing is doing the convert to expression. So we're taking in a filter criteria, or filter type param, or our filter type, etc. We're getting the member info and the expected value and the property type and so on. We need to do some validation here, because that expected value is held as an object, but we need to make sure that that object, or whatever value is living in that object placeholder, can be converted to an instance of this property type. So we're going to need to do some stuff when we're building out our filter criteria. So we should probably validate that right now, or add this validation to the add criteria right now. So, excuse me. Pardon me. If we can't identify the type of the property for this criteria that we're adding, we're building out anyway. Let's ensure that the expected value can be converted to the assigned property type if it can't be, I'd rather throw now than when we try to apply the filter. That works. And I'm just going to get rid of this catch exception EX because we'll just throw a new exception at that point. Expected value cannot be converted to an instance of. There we go. I like that. And that means, let's just get rid of operator. We're not using operator base yet. So let's come out to our filter tests. And where we're adding the criteria, where we've got all of these things. Right? So we're passing a string value into a property that we know is a string. So when we build up the next criteria, I know that renewal period is an integer, so I can pass it in an integer, but what happens if I try to pass giraffe? So if the renewal period is less than giraffe, it's going to pop. We're going to get that argument exception. Here we go. Expected value giraffe cannot be converted to an instance of int32. Beautiful. That's exactly what I want to see happen there. Let's go back to our test. Change it back to 100. And this isn't super understandable. There, that's better. I like that a whole lot more. Let's do this again. Property name. Yeah, it's a little bit more keystrokey, but it's a whole lot more understandable in terms of what the heck is going on with my method calls. I like things nice and explicit and spelled out. It just makes life easier. So, okay. I'm going to keep jamming on this after I end the stream, which is going to happen imminently, because I do want to bring in some superpowers here and perhaps some factory yumminess on these operators so that I can make them even more type safe and validatable, like bring in the ability to do some pre-flight checks, do things like collection searching, and so on with these operators. And then I also need to solve the problem of mapping impedance, where I might build a filter down in my API layer against a type that represents one of our domain concepts. But when we get up to the resource access layer, we're going to need to convert that filter into its equivalent form for however that resource is stored. So I'm going to need to come up with a way to express that mapping in as unobtrusive a way as I can. And that's going to be a really interesting problem to solve. If I can get away from explicit code that maps one type dot property name to another type name dot property name, that'll make me very, very happy. I might have to get into some goofy reflection and stuff like that. And just talking through it right now, I feel like I'm in extreme danger of rebuilding AutoMapper. And if I can avoid rebuilding AutoMapper or reinventing AutoMapper, that'll make me happy. But I really feel like that we can get some idiomatic or idiom conversions, at least semi-operated or semi-automated for use in our code base. And if I can manage that, that'll make me very, very happy, especially if I can do it in a mostly transparent fashion. All right. So until next time, I'm that DeveloperDad. Thanks for tuning in. You've seen how we were able to actually build out a semi-dynamic filter at design time. I'm doing things very explicitly here, but you could very easily write some code that would take, for instance, HTTPS myApp.com/API/subscription templates filter, and I'm just going to let Copilot do its thing here. So we've got that whole thing, right? And then in our API controller or our minimal API method, we could conceivably convert that query string in the URL into a filter object. And then pass that all the way out to our resource access and be good. It'd be pretty sexy. I'm going to bounce. I'm going to keep working on this. I'm not going to do this part. If you decide to adopt this stuff, I will strongly encourage you to do that as an exercise for your own education. Playing with code is fun. You should do it often. Remind yourself why you got into programming in the first place, because it's fun to figure out this weird stuff. And I will see you all next time. Take care and happy coding.